everyone, welcome to Vishesh Educational Videos. In this video, I am explaining some basics of Python programming. Particularly in this video, I am explaining expressions, different types of expressions in Python. So if you are not subscribed to my channel, please subscribe to my channel. To get the notification of my new videos, please click the bell icon. So let me begin the explanation of expressions in Python. Now, to type the expression in Python, we need a interactive shell. So Python interactive shell is also known as IDE, that is Integrated Development Environment. IDLE is a integrated development environment that is built in, right? When you install Python, so IDLE will also get installed with the Python installer. It is built in integrated development environment. Integrated development environment means you can use this idle software to type your Python programs. In simple words, to type your Python programs, you can use this idle integrated development environment. So Python installer mainly provides two interactive shells. So first one is idle. Idle supports graphical user interface. That means you can use icons, buttons, text boxes like that, right? And also you can use command line oriented interface. Both options are available. Either you can use idle or you can use command line, right? Both can be used for running simple programs. So where we run Python programs means we can run Python programs using a integrated development environment idle, or else we can use a command line prompt that is also get installed when you install Python in your system. Next, so how to know that I've installed a Python software in my system? To know, to check that, you have to run the interactive shell by launching idle, which is installed with Python. So on Windows, particularly on Windows system, so you have to open the start menu, select all programs option. There you have to select the Python 3.3. It's not right. It's not actually always. It's not Python 3.3. So many other versions can be also available. You can install in your version what you like the most. The most recent version also you can install. So in this example, I considered Python 3.3. You can click on Python 3.3, and after selecting Python 3.3, you can select idle, right? So how to know that a prompt is open means you can see this. So you can see the symbol, right? Three greater than symbols. A window with this symbol prompt should appear. That's when the interactive shell is opened. So if you, for example, in this example, if you if you type 2 plus 2, it is going to give the result as 4. It is going to do the simple addition and it's going to display the result as 4, right? So a window with this symbol should appear. Only then you can type your expression. Okay. Now, what is expression then? So expression is nothing but it's a combination of operator and operands. So it is going to produce some result. So what is expression? An expression is a combination of operators and operands. For example, you can see this example here. 28, 36 and 5 are operands. Between the operands, what we have? Operator. Here, how many operands we have? We have 3 operands, that is 28, 36, 5. What are the operators we have here? 2 operators, that is addition operator, that is plus operator, and star, that is multiplication operator. So whenever we call expression is nothing but it's a combination of operands and operators. So this expression is going to produce some results. You can see here 28 plus 36 into 5, it's going to display some result, right? So, but the only important thing you should know here is, right, the expression is evaluated as per the precedence of its operators. Precedence means based on the importance. Every operator will have some importance. Every operators have some precedence. Based on that precedence, right, the expression is going to be evaluated. Especially if you have more than one operator, then only the precedence comes into picture. For example, here we have two operators, right, plus and star. Which one is going to execute it first means star. Multiplication operator is going to execute first, then addition will execute, right? So whenever you evaluate every expression, you should consider precedence into account, right? So see, we will see the precedence table here. So this is the table of Python operators precedence rule. So here the operators are arranged according to the highest to lowest order. You can see the brackets and braces are having, that is parentheses, are having the highest precedence. That means whenever your expression contains brackets, braces and parentheses, you need to consider them first. Afterwards you have to consider, right, star star. This is this is power operator, right? We are going to discuss this more in the upcoming sessions. Next, right, so this is negation operator. Next, star operator, modulus operator, division operator. After that, plus and minus. After that, equals to, lesser than or equal, greater than or equal, and next is not operator, and lastly not operator. So based on this precedence only, we have to decide which one to, which part of the expression needs to be executed first. So here parenthesis having the highest order, not operator is having the lowest order. Not operator is a logical operator. We are going to discuss that in upcoming videos. So if you have any doubts, please post your doubts in the comment section. So far what we have discussed means expression. So expression is nothing but it's a set of operators and operands. So every expression is going to produce some results. Whenever we want to evaluate expression, you need to consider the precedence of operators. According to the precedence, you have to evaluate your expression. Now, what are the different types of expressions that are available in Python? The first one is constant expression. So what is a constant expression? These are the expressions that have constant values only. Now you can ask a question, sir, what is a constant? Constant means the value is not going to change. For example, you can see x is equal to 15 plus 1.3. That is 15 is a constant because 15, the value 15 is not going to change. 1.3 is a constant because value 1.3 is not going to change. So constant means values are fixed. The values are not going to change. So the expression that contains constant values can be called as constant expression. So according to this example, this is a constant expression. It is going to add 15 plus 1.3 and it's going to print that result, and the result is 16.3. Okay. Next is arithmetic expression. Now what is arithmetic expression? Arithmetic expression is a combination of numeric values. Arithmetic expression always contains numeric values and also operators and also sometimes parentheses. But the result of this type of arithmetic expression is also numeric value because it contains numeric values as operands. Between numeric values, we use operators. So whatever the result is going to be produced in arithmetic expression is a numeric value. The operators, whatever we use in these arithmetic expressions, are arithmetic operators like addition, subtraction, multiplication, etc. Right? Now we will see some examples. Yeah, you can see here x plus y. X is an operand, y is a operand. Plus is a operator. So in arithmetic expression, you can observe here it will contain numeric values. So you can see in this example, I can give x value as 40, y value as 12. So you can see x value 40 is numeric value, y value 12 is a numeric value. So between that numeric values, we can use these operators. So what these operators are called as arithmetic operators. So what are the different types of arithmetic operators that can be used in arithmetic expression? That is addition, subtraction, plus is for addition, minus is for subtraction, star is for multiplication, right? Bar symbol is for x bar, y is for division, double slash, single slash is for division, double slash is for quotient, modulus operator, that is it is going to give the remainder, right? Modulus operator is for remainder, double star I told you, right? Double star is for exponent. It's for exponent. That means to calculate the power values. So this is just a simple example. It is going to do addition, subtraction, right? Product, that is multiplication and division. By doing all these operations, it's going to print all the results. See, first it will print additions, subtraction, product, division. So you can see the output. 40 plus 12 is 52. 40 minus 12 is right 28. So 40 into 12 is 480. Division 40 divided by 12 is 3.33. So this is the example for arithmetic expression. It contains numeric values. Next is integral expression. Now, what is integral expression? These are the kinds of expressions that produce only integer results after all computations and type conversions. That means in simple words, whatever the results that is going to be produced from these expressions is integer only, right? So we have different types of data types in Python, like integer, floating point, right? So integer means it's going to produce positive number or negative number, right? Floating point means fraction values, that is decimal values. So this integral expression is going to produce only the result that is the integer type. For example, you can see I'm going to consider two values. A is 13, B is 12.0. C is equal to A plus int of B. Int of B means you can see B is 12.0. 12.0 means it is having decimal point, that is floating point value. But I want my result in integer. So that's why I'm using type conversion. This is nothing but type conversion. Type conversion means I'm converting from one data type to another data type. Here my b value is floating point. I'm converting my floating value to integer. So when you add a plus b, your result will be in integer only, because once again, because a is also integer, your b is also integer. You are converting from floating to integer. So whatever the result that is going to produce, again it's an integer. 13 plus 12 is equal to 25. You can observe it's not 25.0. It's not like that. It is 25. So whatever the result that is going to be produced is an integer. That is why it's called as integral expression. So next is floating expressions. So these are the kind of expressions which produce floating point numbers. Simple. I don't want to track this. Very simple example. See here, a is equal to 13, b is equal to 5, c is equal to a divided by b. Print c. So result will be printed here. You are going to divide 13 by 5. So your result is 2.6. You can observe decimal point is there here, because it's a floating point expression. Floating point expression is going to consider decimal points. It's going to consider decimal points. But integer expressions are not going to consider decimal point integral expressions. Getting my point? So next is relational expressions. So relational expressions means, as you know, it contains relational operators like lesser than, greater than, lesser than or equal to, greater than or equal to, right? So it is going to contain this relational operators, but only one thing here is, between relational operators we have arithmetic expressions. Between relational operators we have arithmetic expression. Here you can see p is equal to a plus b greater than or equal to c minus d. See, greater than or equal to is a relational operator, a plus b is arithmetic expression, c minus d is a arithmetic expression. So Whenever you consider a relational expression between relational operator on the left hand side and the right hand side of the relational operator, we have arithmetic expression. That's why in this type of expression, arithmetic expressions are written on both sides of relational operator. And these arithmetic expressions are evaluated first and then compared as per the relational operator. First I am going to calculate a plus b, next I am going to calculate c minus d, and I am going to compare both a plus b value and c minus d value, whether a plus b value is greater than or equal to c minus d. Getting my point? First I will evaluate the arithmetic expression, then I am going to compare using a relational operator, and the output whatever you are going to get, the output is boolean. Boolean means it is going to display either true or false, only true or two values. Output will be either true when comparing, either it will print true or false. So this is just a simple example. You can see here a plus b, I'm going to compute here 13 plus 21 greater than or equal to c minus d. C minus d 40 minus 37. Obviously 21 plus 13 is greater than 40 minus 37. That's why it's going to print the output as true. You know that, right? Your output is boolean. Only true values, either true or false. Next, logical expressions. So these are the kinds of expressions that result in either true or false. Obviously, here also logical expressions are going to produce your result in boolean. Either your result is true or false. So it basically specifies as one or more conditions. See, logical expression contain logical operators. The different types of logical operators are and, or, not. You can see the syntax here: P and Q, P or Q, not P. Not is negation operator. Okay. So P and B means if both the values are true, your output is true. RQ means if both the values are false, your output is also false. Right? Not P means it is a negation. For example, if your input is true, your output will be false. Reverse. So we will just see the example here. 10 is equal to 9. No, it's wrong. P is true. P is true. 7 greater than 5. Sorry. 10 is equal to 9. No. 10 is not equal to 9. False. P is false. 7 greater than 5. Yes, 7 is greater than 5. True. So P is false. Q is true. So see, P and Q means P is false. Q is true. False and true will be false only. I told you. And means both should be true. P or Q, both should be false. But here one is true, one is false. Again, it will be true. Not P. What is P here? P is not equal. P is false, right? No, so not P is, it should display true. See, it will display true. So getting my point? So these are logical expressions. X, bitwise expressions. So bitwise expressions are performed at bit levels. Bit means it's the smallest unit of information. I told you, the computer understands only zeros and ones. So zeros and ones are nothing but binary, right? Zeros and ones are considered as bits. So you are going to consider some operations to do on bits. So that are nothing but bitwise operations. In bitwise, there are two types of operations: bitwise left shift and bitwise right shift. Here I am going to explain bitwise left shift. So one thing you have to remember here: to do the bitwise operation, you have to convert your number to binary first. You have to convert your number to binary, then you can perform left shift or right shift. Here, the symbol is for left shift. One means what? You have to shift one bit. Two, if the value is two, is you have to shift two bits. So I'm going to explain this how it's going to perform uh, bitwise left shift. So here I'm converting my 5 number, right, to binary. So binary value of 5 is 0101, right? 0101. So I grouped 4 bits here. I grouped 4 bits. 0000 first, 0101 4 bits, 4 bits. How I converted that decimal number to binary means here 5. I have to divide 5 with 2 because it's binary. That's why I divided 5 2 twos are 4, remainder is 1. That is remainder is 1. 2 ones are 2, remainder is 0. So you can see here 101. 101 is the value for binary value of 5. But I appended 0 on the LSP, left least significant bit. I appended 0. Why I did that? Because I told you I grouped the bits 4 bits. That's why only I got 3 bits. That is 101 I got, but I need 4 bits. That's why I appended 0 on the LSP. This is LSP and the rightmost bit is the MSP. You know that. Now, how to convert this? See, this is the left bitwise operation. How I'm going to do this means left side bit should be removed. You can see what is my binary value here? 0101. So 0101. I will write that 0101. I will remove the left bit and I will add 0 on the right side bit. So see, I remove the left bit, 0 I removed. When I remove 0, how many bits are there? Only 3 bits. That is, what are those 3 bits? 101. Now, I removed that LSP bit. I'm going to add 0 to the MSP bit. See, 1010. I added 0 plus. Here I removed left bit. I added 0 to the right side of the binary number. That is in MSP. So my final value after doing the left sheet is 1010. So 1010 is equal to the decimal number 10. If you want, you can convert 10, you will get the binary value as 1010. So this is bitwise operation. You are going to shift the bits and you are going to perform the bitwise shift or bitwise right. Here I just explained left bitwise or left shift. Suppose if you have any doubts, please post your doubts in the comment section. So what I did here in simple ways, I removed the left bit and I added the 0 to the rightmost side. Okay. Next is combinational expressions. As the name suggests, we can use different types of expressions in a single expression. You can combine different types of expressions as a single expressions, right? So those type of expressions are called as combinational expressions. So you can see here, this is just an example. I am going to consider two values, a is equal to 16, b is equal to 12. C is equal to, now I'm going to do some operation. I'm going to store that result in the variable C. I'm going to discuss variable in the next video. So A plus B, this is right shift. You are going to do the right shift for B, that is 12, and you're going to add that right shift value to your A. So you can observe here. Here this is arithmetic expression. Left side part is arithmetic expression, right side part is bitwise expression. So I am combining arithmetic expression and bitwise expression to get a combinational expression. Getting my point, guys? So that's it, guys. If you have any doubts, please post your doubts in the comment section. Thank you. Thank you for watching the video.